You own an IP address, a range of IP addresses. Okay? The address that you own, what you bought, is 140.78.0.0. What class address is that? A B, which means you start with Class B subnet mask, right? Okay. I come to you and I say, look, we got a problem. Well, first let me ask you this. So if that's a Class B, how many different addresses are on that one network? I just told you. Nope, the bigger number. 65,000 and some change. Would anybody in here like to manage a network, one network, with 65,000 users on it? Okay, why not? Right, because even if you pay me hourly, I'm not going to work that hard. Besides the work, though, talk to me like a network person. Why won't that network be an efficient network? No.
We're going to have a bunch of IP addresses that aren't in use.
What if every single one of them is in use? What if you really do have 65,000 addressable nodes on your network?
You probably want to break it into smaller.
Why? That's the question. Why?
It'd be a lot easier.
Why is it easier to manage?
It'll slow down.
It'll slow it down. But don't forget, there's all this traffic that's going on. If I have 65,000 nodes on my network, I know I did not go around and assign those addresses individually. What did I use? I used DHCP. Do you know how a client finds a DHCP server? It sends out a broadcast. I got 65,000 nodes sending out broadcasts. I can't stop that. That's the way DHCP works. Not to mention all the stuff you're doing, all legitimate traffic, it's still way too much traffic. It's like driving in Houston in rush hour versus driving in Beaumont. All that congestion, imagine it all the time. So we don't want to do that. We want smaller networks. You start dividing things up. Being a network person is all about control. I want to control what you do, when you do, what kind of traffic you generate, when you generate, all that stuff. Okay? So we're going to subdivide this big network into smaller networks. There are only two approaches to this. What are the two pieces of my IP address? What can I identify? That's what did. That's the only two approaches you have. So I'm either going to tell you how many networks to create or how many hosts I want. That's it. That's all I can ask you for. What we're going to start with is the number of hosts. Okay? So if I tell you, I'm sorry, let me back that up. I'm going to do networks. Okay? Sorry. If I tell you I need 29 different networks. We've sort of looked at the way our business is set up, and what I've decided is I need 29 different networks. Okay? It means I got to go buy a bunch of routers, because what's a router's job? Love it. Connect dissimilar networks. Okay. So I'm just to go create a bunch of dissimilar networks, 29 of them. So your first thing is to know what I'm asking for. I've asked you for 29 networks. So start off, put down the address that you were given. All the rest of this I bought this. It's 140.78. I bought that. That's mine. But because this is my network portion, I don't want to change what my network is known as outside. All right? So all of the host portion, though, I can change. I'm going to cement this in. We're going to write this in stone. I'm not going to change it. But I can do whatever I want to the host portion. All right? I can't change this number because somebody else owns it. Just think of it that way for now. Okay? But I can change this. So you're telling me right now we're starting off with one network, and on that one network I have 65,534 possible hosts. Assignable addresses. I don't want to assign them any addresses. I want more networks, and it's sort of a give and take. If I get more networks, then every network has fewer hosts on it. Okay? You can't affect one without affecting the other. If I want fewer hosts, then it means I get more networks. If I want more hosts, you better buy an additional address. Right? If you have more than 65,000 hosts, I'm not going to help you. You better go buy another address. Okay? Technically, there is a way to help you. We're not covering it. All right. I am not allowed. Y'all already told me that if I wrote the number 255, that was my broadcast address, right? The broadcast address for the 140.78 network is 140.78.255.255, right? To write that in binary, look, y'all let me leave out a dot over here, I mean a space over here. I'm totally blaming you all for that, by the way.
It's 255.255.
255.255, all ones, right? If this is my host portion, then what we're saying is that the broadcast is equal to all ones in the host portion. Right? My network ID is all zeros in the host. So if I were to get rid of this and write all zeros there, you would be telling me that the network you own is 140.78, like I have written up here. Right? Because to write zero in binary is all zeros? Okay. I am not allowed to give away either of these. It's not an assignable address, or it's not a valid address for a host. Because of that, I have to account for that when I'm going to do my calculations. So if you come to me and you say, I need 29 networks, I'm not allowed to give away all ones, I'm not allowed to give away all zeros. How do I account for that? I add 2. You ask me for 29, in order to give you the 29, I'm going to calculate 31. Okay? Just one of the steps you have to remember. All right. I'm going to give us a number line here. Your first question becomes, how do I write the number that I'm being asked for in binary? if I did this, and I said, write for me the number 31 in binary, how would you do that?
Add the first five. It's gonna be 0, 0, 0, 1, 0.
Okay. When we write numbers in binary, even though we are used to dealing with 8 bits, this is the most significant bit. Over here is the least significant bit. If I start with zeros, those are called leading zeros. And in any other place, other than when we're writing it in what we call dotted decimal notation, when we're writing an IP address, we're going to fill in all 8 bits. But if I just ask you, outside of this class, write the number 31 on the board in binary, you would just have to write the 5 bits that are ones. You can drop leading zeros. Okay? So if I ask you, how many bits does it take to write the number 31? It takes 5. Okay, so what we're looking for is, I need to know what you want from me. Do you want networks or do you want hosts? How many do you want? And how many bits does it take to write that number? We're saying it takes 5 bits to write the number 31. Okay? So 5 bits. This is, if I right now draw a line on this, this is my network portion. That's my host, right? Subnetting is about, I need to know where to move this line. You're asking me for networks. You're saying I need at least 29 networks. We accounted for the 2 that we have to throw away. You're going to give me 31. I'm going to take this line that right now is dividing the network portion from my host portion, and I'm going to move it. You asked me for more networks. If I get more networks, I wind up with fewer hosts per network. If I'm going to do network, I am moving my line to the right. How far do I move it? Those 5 bits. So 1, 2, 3, 4, 5. I just moved my line. Now, all of this is my network, and all of that is my host. Y'all are used to seeing subnet masks written as 255, 255, whatever. We're leaving that. That is the class full system. We are now going into the classless. This is no longer a class B address. Right? You can tell me that by default it's a class B address, and I would agree with you, except that we're no longer going to use it that way. So what I have to do now is figure out my new subnet mask. Because you told me that the subnet mask is how we identify what's network and what is host, right? And if I'm looking at my subnet mask written in binary, I would have 8 ones over here, because that's 255. 8 ones, because that's 255, and that's still what I have. But we changed our 3rd octet. But I'm still going to write ones all the way to my new line. Okay? Move the line from here, 5 bits over. All of this is subnet mask. Subnet mask is made up of all ones, right? So now all I have to do is add it up. 128 plus 64 is 192. plus 32, 224, 240, 248. My new subnet mask is 255.255.248. Okay? I'm already getting some of those bullets.
Why did you do it there?
This we engraved in stone. Okay? And what you're saying to me, we own one network. But what we talked about was we need 29 more. I've got one, I want to take the one and turn it into 29. So I own one. I want to turn it into 29. I don't need to change this. What I need to do, let's use technical terms, I need to borrow some bits from the host portion so that I can create the 29 networks that you've asked me for. Okay?
What 248 is in the
No, the 248 is network portion. All of this, from this line back to the left, is network. It just got bigger, this direction, host, and it just got smaller. Remember, it was a combination. One gets bigger, the other gets smaller. Right?
Why do you need the 248?
So that I will know. If I give you an address, if I say your address is 140.78.12, and the subnet mask is 255.255.248, you're going to have to figure out what network that is on. I'm fixing to show you how we figure that out. Okay? All right. From this information, there are 4 things I need. I need to know what network you just created, so my network ID, my first assignable address, my last assignable address, and the broadcast address for that network. All right? We just created at least 31 networks. All right? Just by moving that line. We calculated our new subnet mask, which is now this, 255, 255, 248. So I'm getting it out of my way. Now, I am not allowed, if I put all zeros in the network portion, is not allowed. Okay? Not valid. So I'm not allowed to use, I'm going to get rid of these identifiers. I'm just going to talk about the things that I'm not allowed to use. Not allowed. All ones, all zeros. It doesn't matter if it's in the network portion or the host portion. I'm not allowed to use them. So this isn't valid right now. This is what we call classic subnetting. And in classic subnetting, we don't use what we call the zero network. We will change those rules in a week or so. But for now, we don't use the zero subnet. If I filled all this in with zeros, so I've got all zeros in the host, the network portion and all zeros in the host portion, I have my original address. Basically, we don't use that. So I'm not going to do this. What I am going to do, I'm going to start counting in binary. I'm going to put a 1 right up next to that line. Ignore everything else. Let me do this. If I said I want you to start with 5 bits and count up in binary, I'm going to write the number 1. Write the number 2, 3, 4, 148.7 on up to 31, because you told me that's the biggest number we could write there, okay? Right? Yes, no, maybe? I need to count over here in binary. This, not valid. Grab the next one and put it over here. Then on the host portion, it's just a matter of filling in one of four things over here. First off, write the smallest number you can write. The smallest number I can write is 0, correct? Then let's imagine this goes away. What do I have written up there? Exactly. That's my first network that we created. So we created 140.78.8.0. Right? Add 1 to that. I'm going to come over in the very last bit, I'm going to change that to a 1. Now what do I have written? That's my first assignable address. .140.78.8.1. Now let's go the other direction and let's write the biggest number I can write. You sort of have to remember that your dividing line right now is here between the 8 and the 4 and the second octet. Don't lose sight of that. Write the biggest number you can write. Fill it all in with ones. Now what do I have? Got what? 15? Just 8, 4, 2, 1. So, yes. Yeah, you got it. That is sort of the confusing thing, is you sort of put the line up there to divide it, and then you got to get rid of it, because I am going to write it in IP address format, dotted decimal notation. So that's your broadcast. 140.78.15.255. Broadcast, all ones in the host portion. If this is my line, all of that is my host, right? And now I have all ones in my host portion. What does the broadcast address do? What does it talk to? All the ones, all ones that are in my network? Okay. Now subtract 1 from that. Put a 0 down there in that last bit. Now what do I have? 254 in the last octet. So yeah, this becomes 140.78.15.254. We're done with this. That's your first network. Let's put the number 2. Remember, here's our dividing line. Let's get rid of this. And write the number 2 now over there on the host portion and do that all again. Smallest number I can write. We're going to get this out of our way just because it's easier to see. And now what do I have? Yeah. Your second network. 140.78.16.0. Last octet. Put all the ones in there. What do I have?
78.
And you just have to keep repeating that process until you've answered everything. Okay? The only things that are going to be over here is either all zeros, that's all that can be in our host portion. Now on the network side, we're just going to keep counting up in binary.
So the next one I can get is 32.
I'm going to move that and put a 1 in there. So here's my line. So now what do I have? Imagine this to be all zeros, so I don't have to keep erasing that. Is that okay?
40.178. 24.0.
Okay. So what's the first usable address? Yep. So that makes this one, this is your network ID. This is the first usable. This is the last usable. And all ones is the broadcast. So what's my broadcast address for this? Hold on, do that again. 140.78 dot. Which makes this. Right? So that's the 1, 2, 3. I gotta write the number 4 in binary here. And so what do I have? And my first usable will be? Right? And so what's your broadcast for that? Is that a guess? We're going to start a bidding process now. What's the broadcast? Imagine taking all these ones, putting up there. Which makes my last usable binary, 1s and 0s. Okay? In order to count up in binary, you can either go through, and y'all saw me writing this up here, I can either go through and in my head actually count them, or this is the 1, 2, 4, 8, 16. There's a pattern. This is going to alternate by 1. This line will alternate by 2. This one in groups of 4. Groups of 8, groups of 16. Everything about binary is a pattern. Right? Are you seeing any patterns emerge as we work through this?
Adding by 8.
Increasing by 8 on the third octet. Okay. Let's go back to the very beginning. We figured out it took me 5 bits to write it. I moved my line over the 5 bits. And the the first one that I put in was above the number 8. This right here, technical term for that, because you know I enjoy technical terms, the magic number. As soon as you get this, and when you see the pattern, all you have to do now, without doing any work over here, what's the next one going to be?
48,
40.
And what's after that? I'm sorry, I'm changing numbers on that. Those should all be 140. You can't let me get away with that stuff, okay?
Should be 0 still?
So what is this one?
48.
Yes. The next one? The next one? The next one? You're subnetting. Now, what you have done is created a whole bunch of networks, and we would keep going until you had created at least the 31 networks that got asked for. Okay? Now, if you would like to do that, get out a piece of paper and do that. I'm not going to write 31 networks up here. Okay? What I am going to do is show you a trick to figure out how to know what the last one is. If I want to know the very last address I can give away, put all ones in over here, right? We're not allowed to give that away, correct? Subtract 1 from it. That I can give away. What is this in binary? See all zeros here. I'm sorry, in decimal. What number do I have written up there now? +28 plus 64 plus 32 plus 16. 240. So I'm going to keep going and on and on and on until I get to 140.78.240.0. That's the last network you're, sorry, that's you at 240. That's the last network you're allowed to give away. All right? Yes. Okay? Last one I'm allowed to give away, 240. Except, I want to know, I need you to tell me what the broadcast address is for this network. 2 different ways to approach that. I've got it written up here. Put all ones in here. And tell me what I have written. I've got 240. So my broadcast is going to be 140.2, I'm sorry, .78.247.255. Do you see any other patterns up here?
The last one,
They will do that every single octet. Once I have the first line, I could have drawn out the first line and then +8 all the way down, +8 all the way down, +8 all the way down. But what else do you see? What is the relationship between the broadcast address of one network and the network ID of the next network? I got 39.255.
So the broadcast.
Increasing by 7, okay?
They're all about the
They're all
Y'all are making this way too hard.
one.
One.
By
By one. If you see these, instead of, y'all are so used to digital numbers, we gotta go back a ways, and y'all may be too young for this, but old-fashioned clocks, speedometers, well, most of those are digital these days. When I roll this over, the next number, I only have 255 numbers on here. So when I click that 255, what has to happen to it? It goes to 0 again, and it increments the next digit. It increments the next octet, right? So it's always one less than this one.
It's always one last one, but.
I will use every single address up here, okay? So if this was at 78.39.255, 40.0, right? If I could add one to that, I get this. All right, well, more importantly, if I subtract one from this, I get the previous, correct? So I could actually give you a list and say, give me the broadcast address of this network. 55. The broadcast for this guy. One less than the next one. So it's 140.78.55.255. Now, here's my warning. Be careful. Do not. Y'all are looking at this right now, and you're seeing all these 255s, and y'all are kind of used to that being your broadcast address. That won't always be. When you subnet a Class C address, it won't look like this. Okay? It'll do it for Class A, it'll do it for Class B, but it will not do it for Class C. Figure it out. When you go take a Cisco test, you take your chapter test for this chapter, they're going to give you a list of choices, and then, hey, which one of these is the broadcast? And they're going to hang you up every time. You're going to put something with a 255 out there. The broadcast address is the address that is all ones in the host portion. Okay? Lights on a little bit? A little bit of understanding? Y'all know what a dimmer switch is, right? Here's what happens with subnetting. That light starts to go on, and that light switch has a weight on it, and you'll go home tonight, and it'll get dimmer. And then you'll come back in a couple of days to do this again, and you're going to have to get that light back up there again, all right? This takes practice, and a lot of it, all right? But you already know some of the secrets, right? You already told me that we've got this magic number thing. We already know that that broadcast address is one less than the next network. What else?
So would it always be like that kind of pattern?
Always.
The same pattern?
What about when
Always.
it's Class C, what is the
It's still there.
255 gonna change?
The 255 will change, but the pattern will still be there. Okay? Yeah,
So whatever the magic number is, your first network, that's the increment.
that's it.
So if it were something else, then it would
The increment will change.
add by that much. Also,
Yep.
I had told him that when I was little and I would sit in the back seat and watch the gas pump. That's how I learned how to do this. I was thinking about a gas pump. Because when it gets to the
Those are
9, it
digital
goes to
now
the
too,
next.
though. Y'all are just all messed up. Our digital kids can't get this. Cars not? Yeah, I didn't think about gas pump. Okay? What else is there, though? What's the other pattern? If you know this, what's the first usable address? What's the difference in this and this? It's one bigger, right? What's difference in the broadcast and the last usable?
One.
One. Every single address will be used. The difference is 1. So, if I create this list, I can populate the rest.
The only thing I'm confused on is whenever you get going to 8, you get to the 16 notes, you have to do, you just carry it over and start adding all of them.
Yes. That's always the confusing part when we draw this line, because in our brain we want to keep that separated. That line really is just so that I know which part of this is network and which part is host. So after I did the 8, then you gotta apply these 4 things. All zeros, 1 more, all ones, and 1 less. Okay?
Are we always going to use 5 bits?
No. That depends on the question I ask. Then I put the number 2 in there. That's why I was saying I counted in binary. So I did all zeros, except we said we're not allowed to use that. So then I wrote the number 1 in binary, the number 2 in binary, 3, 4, 5, 6, 7. I would just keep going. But I would always, I'm just looking at the 5 bits that I borrowed to increase my number of networks. Okay?
Once you get down with the 16 bit, the 32-bit.
Well, yes. Don't forget though, we do it this way.
So we zeroed it.
Because there's the number 1 in binary, right? Then plunk in 2, 3, so I have to do 8, 16, 24, 32, 40, 48. If you wrote those numbers, the 3rd octet, if you wrote it in binary, it would correspond to you counting up in binary on the host side, on the network side, network side. Okay? It takes practice. I'm not done. We'll pause there and we'll reset.